One thing I see a lot of on YouTube are people analysing the flight paths of commercial aircraft using these online trackers, and one of the better ones is flightaware.com. We're just going to have a look at Qantas 27, which is the direct flight from Sydney, Australia to Santiago, Chile, and it's just showing there that it arrived 41 minutes ago. It was a 12-hour, 10-minute flight, and what we're just going to do is have a look at the flight path as it appears on the tracker, and then we're going to load in the exact flight plan to my professional app here called ForeFlight, which is a commercial aviation app. And with FlightAware, if you register an account and log in, what you have access to is the full filed flight plan. Okay, you can see there it says, just get the mouse cursor. You see there it says direct, DCT means direct, so it's Sydney, direct to Optic, direct to 35 South, 153 East, then direct to 4220 South, 161, 15 East. Okay, so I'm just going to show you how we can load this entire flight plan into the app, and then what we'll do is just compare how it appears on the globe versus how it appears in these online flight trackers. And then the beauty of this ForeFlight app is you can overlay weather and satellite radar images and get an idea sometimes why the flight paths don't always follow the Great Circle route. They'll do diversions around tropical cyclones or thunderstorms, or maybe just to take advantage of the wind. And the beauty of this program is it can actually overlay wind and radar and cloud and that sort of thing. So what I'll do is I'll just show you how we load up the waypoints. Then I'll pause the video because I'll load up the entire flight route, and then we'll come back and take a look at it. So I've got Sydney and Optic in there already. So let's have a look at the next latitude and longitude. So it's 35 South, 153 East. And that's all you have to do. Just type it in exactly like that. There you go, 35 South, 153 East. Okay, and then just hit return. Just make sure that's right. And you'll see it automatically puts it in the correct format. And if you zoom in, it's showing the route. Okay, so if we just put the next one in just to show you again. The next one is 4220 South, 161 15 East. So we've got 4220 South and then 161 15 East. Okay, just hit return, and again it puts that in. Okay, so you can see the route starting to develop there, and it looks like it's going to go past the South Island of New Zealand. So anyway, I'll pause there. It'll take me a while to put this entire flight plan in, but once I've done that, I'll start again. So I've now loaded all the waypoints for the filed flight plan for QF27 between Sydney and Santiago into my ForeFlight app, and there they are. It did take a while to do that because I had to do them all manually, but it now allows us to analyse the flight route accurately. One of the common questions I see is, why do they fly this curved path? Why don't they fly a straight line between the departure point and the destination? It's actually a very good question. If I didn't have a background in aviation, I would ask exactly the same thing. And the answer is also quite simple. It's because this map is a distortion of what the Earth actually looks like. So a flight path that works on the Earth will not appear correctly on this map, okay? Because it does not reflect the true shape of the Earth. What we need to do is have a look at what this flight path actually looks like on a globe. To do that, we orientate it so that we're looking directly down on top of the route, and you can see that it actually is a straight line between Australia and Santiago. And one of the phrases you might have heard of is a Great Circle route. Now, a Great Circle route is the shortest distance between any 2 points on the globe. If I just put in Sydney straight after Santiago, what it's going to do is draw the Great Circle line back from Santiago to Sydney, and you'll see it basically matches the route. If we zoom in, see just how close it is. Okay, so the actual filed route for QF27 is very close to the Great Circle route, as you would expect. So it doesn't make a lot of sense when you look at it on a flat Mercator style map like that it makes perfect sense on the globe, and that's how you have to analyse these flight paths accurately, by putting them and plotting them on a globe. Then they make sense. Now, the other thing I want to just talk about is these waypoints. You'll see that some of them are quite close to each other, and some are spaced widely apart. Now, why would they do that? Very good reason again. As we're flying from Australia to Santjaga, we're crossing airspace that belongs to different countries. We've got Australian airspace, we've got New Zealand airspace, then we've got airspace belonging to Chile and South America. And what these waypoints are, when they're close together like that, that's telling me that it's probably a boundary where it's crossing from one FIR, which is a flight information region, to the next. And we can actually confirm that on this other app, which is Jeppesen Flight Deck. You'll see as that route goes across different flight information regions, they will put a waypoint here and a waypoint here. So the pilots know when they are crossing from, for example, Australian airspace into New Zealand airspace, and they can report at that position, and the ATC will know the location of the aircraft. So there it is, guys. It's great for anyone doing their own analysis to by all means be skeptical. Don't take my word for it. Get these apps yourself. Load these flight plans in yourself and just analyze them. They make no sense on this map when they curve. They should fly a straight line. The reality is they do fly a straight line. You just have to understand what it looks like on the globe. It's the only place the flight paths make sense. So the last thing I wanted to touch on is that if you are doing your own analysis this way and plotting the flight routes into a program like this and analysing them, you will come across anomalies from time to time that might not make sense. The flight plans won't always be the same, and there will be occasions where they divert significantly off the Great Circle route. There is always a good reason for that, and the main ones being wind and weather. If we load up here, we can actually put in the satellite imagery, and what it's going to do is overlay the current weather. You look up here in the northwest of Australia, there's a tropical cyclone happening. So when we do our flight plans, when we calculate our flight plans, obviously the Great Circle route is the most efficient, but it may not always be the safest, and in some cases it's better to divert even up to several hundred miles to avoid a tropical cyclone. So that's one of the main reasons why you will see variations to the actual filed route. The other thing we can do here is we can load the winds aloft, and you're going to see a whole lot of little arrows now. Okay, now these arrows indicate the direction and the strength of the wind. Okay, you can see here the wind is quite light, and then when you see more of these little lines on the arrow, it just means the wind is stronger. Okay, and that's plotted for the whole Earth as well. Okay, you see up here there's another storm system up in the Solomon Islands. So when it comes to analysing your flight plans, always bear in mind that the Great Circle route is the most efficient, but safety takes priority, so it will sometimes divert around weather, and there may also be significant diversions just to take advantage of strong jet streams. You know, you might want to divert off the Great Circle route to avoid a very strong headwind, or again maybe take advantage of a very strong tailwind. So you know, there are valid reasons why the aeroplane won't always fly exactly the Great Circle route.